So logic gate. I hope you all are studying the. This is there is a logic algebra in mathematics, right?
Yeah.
Yes, sir.
So negation and various and operator or operator and all.
Yes, sir.
Okay.
Yes, sir.
So we have to study something called Boolean algebra.
Yeah, we've done some of this in CS also.
Yeah, correct. So those who are having the CS as elective, you can also know. So Boolean algebra is very simple. We always go by the binary logic. So if we say A is the event of occurrence of A, then A complementary will be event of non-occurrence, right?
Yes, sir.
So what is the probability of occurrence of A or not A?
1.
So this is the first Boolean, you can say Boolean algebra basic, that any event or, now plus is read as or. So either A will occur or it will not occur, which is 100% true, right? So 100% means 1, isn't it? So what is the algebra of occurrence of A and at the same time it should not occur?
Never.
0.
It will never happen. So this is always 0. Okay. So what is the something has occurred, or whether it will occur or not occur, we don't know. So 1 plus A will give you what? It is again or. So 100%
One.
or whatever is 100%. It has happened already, right? So 1 plus anything is always 1. But 1 into anything is
0.
anything. Anything. See, anything I don't know, no? 1 dot A is A only. Why? Because if A is 0, it is 0. If A is 1, it is 1. So if it is A only. Correct? So in the Boolean logic, you just need to know these 4 things, and that is more than sufficient. Okay. So A plus A bar is always 1. A into A bar is always 0. 1 plus A is always 1. 1 into A is always A.
A.
Is this clear?
Yes, sir.
So these are 4 fundamentals of Boolean algebra. Rest, you need to know certain gate actually. I'll keep it very short. So have you all watched the last lecture of semiconductor? Not all. Okay, so we'll start with something called buffer. What is buffer? You draw a triangle. So whatever is input, the same is. So buffer does nothing. Okay. So buffer does nothing. Still, it is used in logic, because we should have all the logic, that it's like bypass. So whatever logic will come, the same logic will appear on the output side. So this diagram is called buffer diagram. What you need to know is the NOT gate. What is NOT gate? I'm not writing anything. What is gate and all? You can read the theory from NCERT or anyway. I'll share notes also if you want to read. So what is NOT gate? In a buffer circuit, put a circle. The moment you put a circle, what it will behave as? It will behave as not. Not means it will reverse the input. So whatever is the input, you will get the A bar. Okay, so A becomes A bar. That's it. So 0 becomes 1 and 1 becomes
0.
0. That's simple logic. Then what we have is the AND gate. So as the name says, in the A and D AND, the D is very prominent. So you just draw a D. And then these gates will have the, it could be one input device also, it could be two input device also. So generally we take as a two input device. So we can draw two input. And then we take a output from here. So we generally represent the output by symbol Y. So this is A, this is B. So A and how we write and dot B. Okay. So A and B is the answer for the AND gate. Then we have OR gate. So how we do the OR gate? OR. But what we do is, while drawing this, you can remove the half part. This is the OR gate symbol. Again, you can create the two input device. And the meaning of OR means either this event or this event. So the way of writing is A plus B. Then we have something called universal gates. So what is universal gate? So we have NAND gate. So basically NAND is an extension of AND plus NOT, or you can say NOT plus AND. It's NAND. Okay. So the first N represents the NOT, and then you use the NAND. So basically, you can draw the circuit the way you want. So we draw the AND gate first. We have the input. Then in series with the AND, we connect a NOT gate. This together is called NAND gate. So what we get here? So if you move one step ahead, what we get here? Output A dot B. But what we get here? The whole bar. Bar why? Because NOT will always make the complement, right? So
Yes.
Y is always A dot B bar. But this representation is not used nowadays. So generally what we use is a simplified notation in which we just put a circle in front of the gate, and that is a NAND gate. So in a AND gate, you simply put a circle, you're done. This is the short notation. And why it is called universal gate? Because every type of gate can be achieved using the NAND gate. So what we get here? Again, A dot B, and the NOT means take the complement. Okay. There is one more gate, I mean two more gate. One is called the NOR gate. Again, I think it's a self-explanatory. NOR means not plus OR. So you draw the OR gate. And in series you connect a NOT gate. If A is and B are the two inputs, what will get here? A or B. And this NOT will make it to what? A or B whole bar. And there is one more gate that's called exclusive OR. So the way to show the exclusive OR is draw the OR gate and just draw one more line like this. And the output is somewhat interesting. It is A bar B plus AB bar. So now I'll explain through some simple logic. So let's say if I promise you to have ice cream if the day is either holiday or Sunday. So which you get? Either you will get ice cream when you will get the ice cream? Either Sunday or holiday. If it is any holiday, I'll give you the ice cream. Which gate? OR gate.
Or.
I will give you ice cream only when the day is Sunday also and it is also some holiday as per the calendar. Which gate? Sunday and holiday. So this is AND gate, of course, the name itself is AND. Okay. And the third case is very interesting. I'll give you ice cream if it is either Sunday or holiday, but not both. I mean,
That's
it
all.
should not be both at the same time. So I'll give you either it is Sunday or it is holiday, but not both. This is called exclusive OR. Either Sunday or any holiday, I'll give you ice cream, but both should not occur together, but not on those Sundays which are also holidays, but not on those Sundays, no, Sunday, which are, I don't know, right, which are also holiday. I hope this is clear. What is this? Is called exclusive OR. So this is also called a XOR gate. How is it? XOR. X means exclusive. OR is also called XOR gate. So once you know all these things, then we can go to the transistor part. So those who have attended the last lecture, they know that any common emitter circuit, so let's say if it is, let's say the emitter is grounded and this is 5 volt, which is like high potential. So if it is either cutoff region, which is like the input is unbiased, or if it is saturation region, it means both are forward bias. So if both are reverse, I mean biased, or if both are forward bias, if input and output are either both are AB, if both are AB, then this mode is called, what do you call it?
Saturated.
Saturated or saturation region. Or if both are reverse bias and or in fact unbiased, okay, this is called
Cutoff.
so only in these two regions it will act as switch. And any transistor in common emitter configuration, it will act as a NOT gate. So this is a NOT gate, which means if you obtain the output here across this, so generally we take the output across this, you can think this way. And this is the input somewhere. Okay, I'm not showing you. This is NPN transistor. So if it is not gate, then what we can do? You can replace this transistor by a simple circuit. This is your equivalent gate equivalent of a transistor. So no need to worry, it is always a not gate. So if you want to solve in a question, just replace the transistor by a not gate and you can proceed accordingly, you will get the answer. So no need to worry about what exactly is the gate, how it is biased and all. So whenever it is used as a switch, it is always used in a either saturation region or cutoff region, and in both case it will act as not gate. In saturation, what you get output is 0, input is 1. This is saturation, and if the input is 0, the output is 1. This is called. So in cutoff, the input is unbiased. You can think of it's a no input. So when there is no input, you get the output. But when there is an input, you will get nothing. Okay. The next concept which you need to know is the idea of pulse. So generally, the input of the logic gates are a pulse. A pulse is a way of giving a binary value of 0 or 1. So let's say if there's a pulse which I draw like this. So a higher value you can think as 1, 0, 1, 1, 0, 1, 0, 0. This is called pulse. Generally, instead of A and B, they will give you the pulse of A, pulse of B. So let's say this is A given to you, some input pulse of A, and exactly below you can draw the another pulse. And the way they ask the question is, okay, first connect this. So let's say we have another input B, and it is like this. Then if you try to write the corresponding value, it will become 0, 1, 1, 0, 1, 0, 1, 0, 0. Okay. And given these two pulse, you're supposed to plot the output pulse for the given gate configuration. So they will give you some gate, and you're supposed to plot the Y, how the output will look like. So just to have some practice, what will be the output for the AND gate? Let's draw the AND gate. So in AND gate, what we get? Tell me, guys. A dot B. Okay. So look at the term, I mean, part by part. So the first is 1 and 0. What will be the answer? You can see here. Can you guys see this? 1 and 0. How much? 1 and 0, and we'll give you 0 only.
Yes.
0 and 1.
0.
0.
1 and 1.
1.
1.
1 0.
0.
0.
0 1.
1.
0 and 1.
0.
1 0.
0.
0.
0 1.
0.
0.
0.
0 0.
1.
1.
0 0 1. 0 0 0 only, no?
0.
Nothing or nothing is nothing only, no?
Acha, okay.
It's not a number, it's just a like probability or idea or event you can think. So 1 and 0.
0.
0.
See, the question is, what is the chance of occurrence of something at the same time nothing? A and B should occur together. So if either of them is 0, it has not occurred, right? Because the question is, what is the probability of occurrence of both? If anyone has not occurred, so the answer is not occurred.
Yes, sir. Got it.
Understood?
Yes, sir.
So if you try to plot the Y in this particular case, I'll just do it here only. Then only you can understand. So I think there's only one, instance of 0 is 0. Okay, I need to draw this. Okay, so now tell me. The first answer is what? The first part is
0,
0. Then next,
0,
then next,
1,
1,
next,
0,
next,
0,
next.
0, 0,
0,
0, 0.
This is the answer. So in the context of and get, I gave you this answer. Now, how to solve the complex circuit? Like when we have a lot of gate in which the A, B, C all will pass. So how do we solve it? Okay. One more thing, that if you are using the NAND universal gate, say you are using the NAND gate, and you're not giving the two input, you're giving the single input. If you give A, what will get here? So I think one logic I need to also add. What is A dot A? What is the occurrence of A and A?
Sir, 1,
It is A only. I want. Occurrence of some imaginary box. I mean, A is not defined. So occurrence of A and A means A only, because if A is 1, it is 1. If A is 0, it is 0. So whatever is A, the answer is A only, right?
okay,
0 dot 0 is what?
0,
1 dot 1.
1,
So A dot A,
A,
because if A is 0, answer is 0. If A is 1, answer is 1. So A dot A is. So what is A plus A? Is it 2A? What is A plus A?
A1, sir.
A1. Yeah, A plus A is A always. So even if I write A plus A plus A plus A plus A plus 1,000 times, what is the answer?
A,
Yes.
So only if I multiply even things like n number times, what is the answer?
A.
It is A1. Okay. So this is simple Boolean algebra, which will help you in simplifying the complex equation. Okay. Yeah. Okay, now if the diagram is shown to you like this, it means the two input I'm giving is A and A. What I'll get here? A dot A bar. What is the answer? A bar. Because A dot A is A and the bar is bar. So what we got the answer?
Yes,
The A become A bar, isn't it? Similarly, if you have OR gate, and if you give the single input A, let's say this is NOR gate, not OR. This is NOR gate. So what will get here? A plus A bar, correct? Which is
A
A
bar.
bar. If you have AND gate with single input, it will act as a buffer. A dot A, which is A, so it's a buffer. And if you have the OR gate with single input, it will again act as a buffer. A plus A.
Yes,
So it means whenever we have the NAND or NOR with single input, you can replace by NOT gate, not to solve much. And whenever there is a AND or OR gate with single input, just replace it. It's like doing nothing. I hope this is clear to all of you.
yes,
Okay. So now let's solve some complex question. So I'm done. I can just show you how to solve question directly from here. Any question I can solve quickly. This is where the logic gate. This is the answer. Logic gate is below. No? Logic gate. Just and also I will advise all of you to keep on revising the semiconductor, because although it's very easy, you're going to forget. Okay, so let's begin from here. So can you see, guys, this new screen?
Yes, sir.
Yes, sir.
Nice, done. So B will give you what? B bar. A will give you A bar. And this is the NAND gate. What we get? B bar dot A bar whole bar. Correct?
Yes.
Is this clear to all of you? How are we getting the answer?
Yes, sir.
Now there is a famous, okay, I'll go back to my notes. I mean, this should be part of notes only. Okay. So you have to remember only one single law, De Morgan's law. What is De Morgan's law?
Cut the line, change the sign.
Break the line, change the sign. So A dot B whole bar, we can write as A bar, B bar, but now dot becomes plus. So when you break the line on individual, the sign will change from dot to plus, plus to dot. So what is A plus B whole bar? How to write?
A bar dot B dot.
A bar dot B bar. Okay. And if it is A bar bar, A bar bar bar. So if it is odd number of bar, it is complement. If it is even number, then nothing. Nothing. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What is the answer?
A.
A,
1, 2, 3, 4, 5. What is the answer?
A
A
bar.
bar.
Okay, smart enough. So break the line and change the sign and keep on doing till you make it simple. Okay, so that's why now we'll go to our question. Done. This is only theory, and you can solve any question now. All right, so let me begin this question once again. So this is B bar, this is A bar. Yes. So what we get on this side? See,
B
the
bar dot A
NAND you
bar.
can think as AND plus NOT. So first you think of AND. So A dot B, whatever it is. And NAND will make it. Now break the bar. What we can write here this is B double bar plus A double bar.
Yes.
So it is A plus B. Which gate?
Or
Or
Anyway, so you know this is answer. So now this is 0, 1, 0, 0. You can think of it. 0, 0. I think 1, 0, 0, 1, 0, 1. Okay, I don't know why this is this way. Anyway. And here what we have? 1, 1, 1, 0, 1, 1, 0, 1. I think maybe mismatch. So what will the answer? Our final gate will be, you can draw on here only. So y will be what? Just think of OR gate. So 0, 1, wherever it is a single one, answer is 1. So 1, 1, 1, 1, 1, 1. Okay, 0. 1, 0. There's no 1. I mean, I don't know why they have shifted this graph, but this should be the answer. Can you check the answer? Oh, but what they ask? Which gate? Just a minute. Yeah, this is a graph, right? A. Which
No, sir. You are one page down. You have to
okay, I'm
go.
one page. Okay, just a minute. This is the graph, no?
Yes, yes. Option B.
This one.
Yeah, left.
Option B. So option B is matching. Yeah, it's matching.
Yes.
Kind of. Okay, so this is the first question we solved. Now we have to come to the next this page only, right? So question is clear how we are solving this question?
Yes, sir.
Yes, sir.
It's very easy. Just a minute. Look at this. Okay, next question is very easy. This is what? Not. A bar, B bar, C bar. Do you remember this? And this is NOR gate. So add A bar plus B bar plus C bar and whole bar, which means A, B, C. Which gate? All must occur together. Which gate is the property of this?
And
And
C.
Done. So simple answer. Okay. Any, just take any question. All questions are very easy. Okay. I'll just show you how easy this is. This is very easy. Okay. And there is no need to draw the truth table and all. This is old fashioned. Truth table is old fashioned. So now this is A. A will come here also. A. B will come here also, and B will go here also. So far, so good. Any doubt in this? No. So this is what?
NAND.
Which gate? NAND. So what will get?
A dot B.
So it is A dot B bar, correct?
Hmm.
Now this will go here. A dot B bar will go here, and it will also go here. We'll solve it in the end, and this will is A plus B, right?
Yes.
This is A plus B. And this is simple, typical AND gate, right?
Yes.
A dot B whole bar dot A plus B, correct? Isn't it?
Yes.
Yes,
And then the Z is what? It is NOR gate. So Z is what? A dot B bar plus A dot B bar dot A plus B
The whole
whole bar. Now we are just supposed to simplify this. Can we take common here something? Can we take something common here? Yeah, you can take. So
Sir,
you can
can
take A
we
dot B
take
bar.
A plus A dot? Yes. Sir.
Yeah, you can take. So once you take what you get, bar, keep it bar. So A dot B bar 1 plus it's a dot, no? So this will become 1 plus. Okay. So then to break this, or we can break first. That's easy. Actually. Breaking is easy. Then we can take common. Anyway, you can take a common at any stage. But let's break the sign. So A dot B double bar. Let me remove this. A dot B. So first we break from here to here. This is one term, this is second term, and we are breaking it. So double bar. And then dot becomes, the plus becomes dot. And then A dot B bar dot A plus B as a whole bracket, whole bar. Okay. I think we can write like this. And this becomes A dot B. So A dot B. And then also we are dot with this entire term, which you can further break. So if you break, what you get? A dot B bar bar plus A plus B bar, right? This is easy now. So what are we getting? Tell me, guys. A dot B dot A plus A dot B plus A bar dot B bar, isn't it?
Yes, sir.
yes, sir.
So A dot B and then A bar dot B bar. Can you simplify further? And what is given? When the input is 1, 0. Okay, so now I think we can substitute and get the answer, right? Not a big deal. I mean, anyway, you can do it. So 1, 0 means if you get any 0 outside, it's 0 only. So this will give you 0. So 0 into anything is 0. 0. This will give you
Sir?
something. Yeah.
Sir, can we like further simplify it to just A dot B?
Yeah. Actually, this will become A dot B dot A. Yeah, we can do this. A dot B dot same thing plus A dot B
Sir,
into.
no, sir. Like basically, we are canceling out the case where A
No, this
dot.
is same. No? This is same thing. I mean, this is same term. No? A dot B, A dot B. So we can make it only one term, right? A dot B.
Yes, sir.
And we can then take A dot B common, so it will become 1 plus A bar dot B bar, right? And 1 plus anything is 1. So this is eventually A dot B. So this is actually AND gate. Do you realize this, guys? This is AND gate.
Yes, sir.
Yes, sir.
And because this is AND gate, so we know the answer. So 0, 0, 1, 0. Well, you're not supposed to solve every term and go through each gate and get the answer. That's cumbersome. Generally, we simplify, and when we have simplified version, we just try to check the answer. In most of the case, it will end up with AND, NAND, NOR, or that's it. Okay. So it cannot be complex forever. Is this clear, or shall I go to next question? Or explain here again?
Clear.
Clear, no? Just a minute. Yeah, 74 is also nice, I think. Looks nice at least. Okay. So 74, which gate you can think of? If both are open, you will get nothing here. No biasing, correct? So this is 0. If this is open, this is 0 voltage. Yes or no?
Yes, sir.
Yes, sir.
Okay. But if you close any one of them, either A or B, this will be 5.
Yes, sir.
Yes, sir.
Isn't it? Oh, okay, first of all, think of these two are parallel circuit. Every parallel circuit will act as OR gate. Isn't it? The path is said to be closed. Either A is closed, B is closed, or both are closed. Yes or no? Tell me. Hello, hello, hello.
Yes, sir.
So whenever I close A, I'll get the answer 5 here.
Yes, sir.
If I close B, I'll get the 5 again, which means the transistor will be forward bias.
Yes, sir.
And if the transistor is forward bias, and the output will be what? If you remember, it is going to be 0. I mean, anyway, this will act as which gate? NOT gate. Transistor will act as NOT gate. So this is like a OR gate plus NOT gate. Isn't it? This is OR gate. Hello, hello, hello.
Yes, sir.
And transistor will act as NOT gate, we have discussed in the last lecture also.
Yes.
So OR plus NOT is what? NOR gate. Come on.
Yes, sir.
So
Yes,
if
sir.
both are open, the answer is 1. Because if both are open, the input is not biased, and therefore the output voltage will be 5, which is high voltage, which is 1. So it's a binary 1 or logical 1. So anything above 5, I mean, certain threshold voltage we call 1, and anything below certain threshold voltage we call 0 in binary language. Okay. So are you able to realize this is OR gate? No.
Yes, sir.
So OR plus NOT, answer is NOR. And where is the answer for this question? Let's check. It's above, answer is above. Oh, what they're asking, which answer? A, B, C, D. Which answer? A plus B bar.
A bar plus B bar.
A bar dot B bar.
Sorry, A bar dot B. Yeah, the
Which
sign is
option?
B.
Option D. Do you realize, guys? No.
Yeah.
See, the first path is A plus B, which is the OR gate. The 2 diode circuit is OR gate. And transistor is NOT gate. So break the line,
Change the sign.
change the sign. Option D, is this clear, guys? Tell me yes or no.
Yes, sir.
Very good. Just just Okay. Next question. We can solve all questions. One more. 75. Just find the gate nature. Just call A this as A bar because they are giving 1 and 0. Okay. So if I take A as 1, the other becomes A bar, which is 0. So what we got here? A bar. This will come here. A bar. A bar becomes, because this is NAND gate with single input of A bar. The answer will be A here.
A.
This A will come till here. A. And A bar and A in NAND becomes what? So A, see, A dot A bar is always 0. So NAND is always 1. Oh, didn't get. So what
Yes,
we're
sir.
getting here? A dot A bar whole bar, which is like A bar plus A, which is always 1.
Yes, sir.
So this is always 1, permanent 1. No need to think much. So this is always 1. And then what we're getting here is A bar, which will revert to become A. So this become A and 1. So A dot 1 is always A, and then this is always A bar. Okay. So Y will be how much? A bar, correct?
Okay.
And because Y is A bar, so what is A here? 1. So A bar is 0, or you can say A bar is 0. So in the given circuit, Y is. Just check the answer. I don't know. Anyone can check the answer for me. Is it? What is the answer given? 75?
Yes, sir, it is there.
Yeah. It's obvious. I mean, is it difficult? Hello, hello, hello.
No, sir.
No, sir.
No, sir.
Just keep on solving. And this is very easy. Next question. 76. No. 76. Which of the following gives a reversible operation? So which one is a reversible? What does it mean? What kind of diagram is this? This will give you not get single input nor
Yes.
single input nor is
Not.
not done. I think this is the answer. You can check. Now need to check that.
So what does reversible mean here?
Reversal means make a 1 to 0, 0 to 1.
Oh, okay.
Reverse it.
That way.
Of course, that is the only way. I mean, of course, it cannot be the reversible adiabatic process. It's not thermodynamics. Anyway. Next. All our time pass. Tell me the answer for 77. Is it difficult? Tell me the answer. Here you have to draw the truth serum. 0, 0, 1 and 1, 1, 0. It is certainly something like that. 1, 0, 1, 0, 1, 0. Everything is okay. I will solve it. What is Y coming in terms of Boolean algebra? What is Y coming? Y equals to how much? A B A plus B A dot A plus B whole bar.
Yes, sir. Same. A plus
What?
B dot A whole
Simplify, no?
bar.
Simplify. A plus B dot A whole bar. Correct? It is A plus B whole bar
Yeah.
plus A bar, which is A bar dot B bar plus A bar. Taking A bar common, A bar dot 1 plus B bar. 1 plus B bar is always
1.
1, or anything dot 1 is anything. So it is not get. So it only depends on value of A. It is correct.
Yes, sir.
B whole bar plus A bar. A bar dot B bar plus A bar. A bar dot 1 plus B bar. The answer should be only function of A. C is answer.
C.
0 0 1 1 1 1 0 0. Isn't it?
Yes, sir.
You can check the
Yes, sir.
answer. Is the C answer given?
Yes, sir.
Nice. So we can simply reduce the effort without going through all the table. It is not good. Okay. Next. These are very easy. Okay, can you solve? I mean, I have been solving now. I think you have got the idea how to solve. Just solve this question and tell me if you have any doubt. How much time you need to solve all? From 78 to 84? 10 minutes?
5 minutes.
Fine.
5 minutes.
Solve. See, this is like a sure shot marks in the examination if it comes by chance. So in some of the shift, it is going to come. Some will be lucky to get logic, and some will be not lucky to get transistor question. Some will be lucky to get diode question. Now, who is lucky? I don't know. How many questions are there total in logic gate?
Sir, they are in 97.
96.
97.
97. So I think you can do all question in 10 minutes. So finish all question. I mean, don't wait for this. Just finish it, and if you have any doubt, I'll solve. Then we can go to the next chapter. No need to practice again. Just understand how to do it, how to write. And whenever you want to take common, convert into, okay, you can always write a as a.1, isn't it? So let's say if you want to, we have something a dot bar, b dot bar, and we have a bar. So you can always write as this is dot 1, and then you can take bar common dot b bar plus 1. You can always do this. And the day you will get something like this. It is a bar, which also means the answer has no effect on b. So b can have any value. So it could be multiple choice questions, isn't it?
Yes, sir.
So you have to be, see, if I'm not able to get the Boolean algebra correct, you will struggle with the table. I mean, I have never read the table. I only solve this the Boolean way. So truth table is of no use. After a long, I mean, later on we are going to learn something called K map in the digital circuit. K map. It's called the Karnaugh map. I think Karnaugh map something, which we use to solve more complex circuit. So how many of you have the electronics as elective? I think Dars is having, right?
No, I have CS.
CS.
But-
Anybody else having electronics? Okay. So all are with CS only.
No, sir.
Which one you have part?
Sir, I have electrical maintenance.
Oh, maintenance. Good. So are you able to maintain your household circuit?
Sometimes, yes, sir.
Okay, good. Aeronautics. Good. How many are done?
I have done 78, 79, 80, 83.
Okay. Done.
Sir, till which question?
All question 96, 97. How many you
Sir, not yet.
finished?
Sir, I'm doing the 87th one.
No, it's only 10 question can do it. 10 question, 10 minutes.
Sir, could you explain the 85th one?
85th. Let me see first. 85th. Hmm. So this is like a diode, right? This is not
Reverse.
diode, it's a diode. So now the thing is, the one end is minus, this is what VCC minus 6, eh?
Sir, is it +6 or -6? Not sure.
As per the writing, it is minus 6, but I
Like,
think
is
it should be
it -6 or -? Is it the dash or is it a negative sign?
even I'm not sure, but anyway, just let me see. Okay, what I can think of one thing. Okay, if A is let's say high potential, if this is high, it is reverse bias,
Yes.
and if it is reverse bias, then I think this should be equal. Hopefully.
Yeah.
So if A is reverse bias, and let's say if A is 1, B is both are 1. If both are reverse bias, then what will happen? No current will flow. Correct. No
The
current
will
will.
flow from VCC to V out, no? Directly.
Yeah. So this potential will be same here, I think. No,
So V
this
out.
is no, this is you're getting V output here, no? So current will go here like this. If it is like this, 6 by 10 kilo ohm.
Sir,
Yeah,
sir, this one's related to last class, right, sir?
yeah.
Okay, sir.
So just remember, this is the minus. Why they have to -6? Which logic gate operation the our circuit does? Okay, so we have to just check the function, the input and the output. So one should be like a biased, and one is one. See if A and B are like this is voltage.
So if either of A or B are low potential, then current will flow from VCC to the terminal, right? Instead of going to V out. Is that how
No,
it works?
V out is you're measuring across this resistance.
Okay.
So whatever is the current flowing here, that current into R is the V out, because V out is from here to here, right? 0 volt and V volt. It
Yeah.
is just a terminal, right? So potential of this end is the answer, isn't it?
Okay. So if any of the A or
This
B
is
are
V
at
out.
low potential.
Yeah. It means if there is a closed circuit, it will happen.
Okay.
And VCC is like, of course, we know this, what is VCC, but is this the diagram exactly? Or are we missing something? Just let me, that's why I'm confused. It's VCC -6 volt, why they have it? Because logic one is more than 5, right?
Yes.
More than
It should
equals
be
to
6
5.
only.
Huh?
I guess it should be 6.
I think also this is 6. I mean, minus is meaningless here.
Huh.
If this should be equal actually. And if I make it 5, then this is higher potential, this is low, so this is the forward bias. Correct?
Hmm.
If it is 5, if it is 6, then it is forward bias. So therefore, this is 6 volt. This is also 6 volt. And 6 minus I. So V out is, it doesn't matter. Okay, I got it. It seems to be the PN junction. If it is 15 and 10 kilo ohm. And these two are in 5. The diagram is very confusing. Is it a transistor or what? Because if it is a transistor, we can think of how to show it. Online April 19, 2014. Okay, you solve other question. Let me check the diagram. That is 6 equal 6. That's not minus. It's equal 1. This is equal 6. Okay, let me see. And if A is 5. Okay. So logic 1 is more than equals to 5, and this is okay. This is if A is 5, it is going to be 4 bias. It will be more than 5. And it is less than 1. Yeah. So if it is more than 5, then the difference is less than 1. So it's logical 0, right? And this is 5. I think this should be or get only. I mean, or get. If A is 5, the difference is less than 1 or equals to 1. If the difference is less than equals to 1, it's a logical 0. So which part is 0? So making A5 gives us logical 0. This is this kind of circuit I haven't seen. Because what I can see, this is always 6, right? If we go by the biasing case, this is always 6 volt. And if we go like this, it's 0. So V output is always 6, no matter what is A, what is B, does it matter? What is A is I think I'm getting that. It has to do with the transistor only. See, if either A or B, if either because VCC is like a bias voltage of the output side, right? Collector side. That's why this is VCC. And if that is VCC is the collector side, then A and B are the two input to the base. If either input will work, the output will be 0. Correct? If either will work, A or B, so if you remember the idea, the output we write as VCC minus IC load resistance, if you remember.
Yeah.
So as long as we have the input forward bias, it is if this is 5 or you can say this is 5, but more than that, and not 5 because this is high voltage, so this will be okay. This is we have to make it forward bias, so we have to make it a small value, right?
Yeah. Low.
Yeah, 1 volt. If either is low, this will carry some current, and therefore this will be output will be also 0. So 0. If A is 0, this is also 0. If B is 0, this is also 0. And if both are 1, then it will be 1. I think AND gate is coming. Can you check the answer? I'm not sure what this should be. AND gate.
Yeah, they're saying and.
Because it is coming one only when both are high potential. If both are high potential, it means both are reverse bias.
Yeah.
Both are reverse bias means the input side is reverse bias.
Yes.
Input is reverse bias means IC is 0. And IC is 0 means V output is VCC. From this equation. I think this is somewhat connected to the transistor only because of VCC I can understand, but I haven't seen this diagram. So V output is VCC minus IC. So the moment we have IC, this becomes less, and so 0 answer. So IC will be absent only in the case of when both input are reverse bias. Okay.
Yes, sir.
If both are yeah, correct. If A and B are high value, it is reverse bias. Then answer is 1. If anyone is low, it's 0. So 0, 0, 0, 1, 1, 0. So it's the AND gate. Okay. Now, and this is difficult for you, I think. Basically, this question is like this question. So instead of biasing here, we have 2 paths of biasing. It means you can bias this input by 2 ways. And because of this diode, this will be forward bias when this is 0 actually. So if both are 0, it will be forward bias. And if it is forward bias, then output will have current. And if output will have current, then output will be, if IC is there, then the V output becomes a small value, which means logical 0. So if both are blocked, it means if both are high potential, then it is reverse bias and output will be same as 6 volt. So no current will come into picture because this current will come because of the IC. And IC only comes, if you remember, IC in transistor only comes when input will give some current. Do you
Yeah.
remember that?
Yeah.
So if input is not giving anything, then output cannot have current. So this, if this RC will, this R will do nothing if there is no current. So that's why this is to do with the transistor only. That's why this is a question. Okay. The rest are done. Any other doubt? Tell me any other doubt. Hello, hello, hello. '86, '87. This seems to be a nice question. So this is not get, right? If you remember. And we don't have diode here. So in a way, this is direct. So as long as if A is forward bias or B is forward bias, C will be 0. So if A and B are either of them are high, C will be 0. It will act as not get, right? Hello, hello, hello. It's the same. It's a not get. You think of not get. Not. I think this is a C, right?
So,
Yeah.
so should I look into this question after viewing the previous lecture?
Yeah, for transistor question, yes, you have to watch the last lecture. It is the last
Okay.
topic of the last lecture. Yeah. But before, I mean, apart from transistor, you can solve rest, right?
Yes, sir.
So which gate is acting this way? I mean, this A and B. Not gate. If any circuit, see the first circuit A, and the output of the first circuit will go to the second circuit, the terminal. Okay. And biasing is done with the first circuit, the 5 volt. If A is 0, then C becomes 5. If A is 0, C becomes 5. If C becomes 5 and B is also 0, then eventually it is 5 only. If A becomes, okay, if both are high potential, and because both are coming together, so it's like A and B. I think it should be A NAND B. A NAND. It's a NAND gate. A not A not. And then it's a not of add. Yeah. So C is basically A plus B bar, right? No, A. This is together. A dot B bar actually. A will come here. If this will try to put A bar. This is A bar. So 5 is low. If this is low, it is 4 bias. If this 4 bias difference, it will activate the 0. He gives not Just check, is the answer A?
Sir, yes, sir.
Transistor gives the not function, and C will get either, because C will be driven by any of the input. If any input will be, if any device is active, it will drag C to 0 value or lesser value. So it is like a C will get the answer either A bar or B bar. And A bar plus B bar we can write as A dot B whole bar, right? Yeah. So it's a NAND group because this is AND bar. So it's not plus and NAND, right?
Yes.
So C will get either answer, either because A will become A bar and B becomes B bar. B becomes B bar. And C will get either of these answer, either A bar or B bar, because if anyone is active, it means current will be established, and once current is established, we always get the output to the less value. The only case in which current cannot be established is when A and B both are reverse biased. If both are reverse biased, it means it is 0, 0, 1, 0, 0. A0, B1, 0, 1. So both are, this is 1. This is 2. This is 2. If both are forward bias, then it is 0. Okay. If either transistor is switch off or cut off, if either transistor is cut off, what will happen? The circuit will be open circuit. And if circuit is open circuit, then only 5 will appear here. When both are saturation, when both are active, then only current will appear in the outer circuit and C will drop to 0. Okay, again, it's based on the last lecture. Any other question like this you're getting here?
Sir, the last
Yeah.
question.
Last, let me check this. This one.
Yes, sir.
In the circuit below, A, B represents 2 input and C represents output. The circuit represents. This should be easy. This is simple buffered circuit. This is buffer, right? So if it is forward bias, then the A to C will be the current. If A is 0, if A is forward bias, it's open, it's a closed circuit, and this is open circuit. So you will get the C value when C means if there's a current through this. So current will come either through this also, this through this also. Correct?
Yes.
If either is active, if A is active, I think it's the same thing. A current will be established. 5.
Sir,
Otherwise-
I don't understand.
Yeah, just a minute. See, for the current to flow, we must have a closed circuit, closed loop. Okay. So let's say if I say this is 5 volt. Okay, let's say this is 0 volt. And this is 0. So now the circuit will look like this. And this is an open circuit. So B is, means this this diode is open circuit. This is voltage V. This is grounded. This is R. So current will be how much? E by R. And the potential difference we have to find is this is V output. So V output will be how much? If current is there, then only there is output, IR. If there is no current, V output will be 0.
Yes, sir.
So we need current here, right? To get V output in this case.
Yes, sir.
And to have current, we need to have at least one of them active. So which gate? I think OR gate should be answered.
Okay, sir. Sir, what does C represent here?
Where is C? C is the output. Why? C is the voltage actually. You can think of voltage. I mean, here C is the terminal, just name of the terminal. And we have to interpret as voltage. Like we are getting V output here. Okay.
Okay, sir.
And to get V output, what we need? We need current across the resistor, right?
Yes, sir.
If there is no current across resistor, what will happen, guys? IR will be 0.
Yes, sir.
So V output is 0, isn't it?
Yes, sir.
Yeah. So what is the answer given? Is it OR get something else?
Sir, or gates.
OR get. Yeah. So that's logical actually.
Okay, sir.
Rest done, guys. Can we start the communication?
Yes, sir.
Yes, sir.
Okay. So let me start communication. What I'll do is I will end the lecture and we'll restart so that we can have a different recording. Okay, I'm ending the lecture. You can join again in 30 seconds.
Okay, sir.